Take a careful look at this object. It's a genuine asteroid, roughly as large as a multi story building hurtling toward Earth at incredible speed. Can you spot it? Almost nobody could. That's exactly why what happened next caught the entire world by surprise. February 15th, 2013, the city of Chelyabinsk, Russia, begins like any other winter morning. People head to work, students make their way to school, traffic moves through the streets. Then, without warning, a brilliant streak tears across the sky. For a brief moment, daylight becomes even brighter. Some witnesses later said they could actually feel warmth spreading through the freezing air. Far above the city, a space rock enters Earth's atmosphere at nearly 67,000 kilometers per hour. Only seconds later, around 23 kilometers overhead, it violently breaks apart. People rush toward their windows, trying to understand what they've just seen. Then, long after the flash has disappeared, the real danger arrives. Roughly 90 seconds later, a powerful shockwave crashes across the city, shattering thousands of windows and injuring more than 1,000 people. Within days, tiny fragments from the explosion have traveled around the globe. The most unsettling part? Nobody knew it was coming. Now imagine that object hadn't been the size of a building. Imagine something vastly larger. Scientists at the Kitt Peak National Observatory were tracking the paths of asteroids moving through space. During one of their routine observations, they spotted something alarming. An asteroid known as 99,942 Apophis appeared to be heading directly toward Earth at an incredible speed. At the time, early calculations suggested that it could collide with our planet in 2029. And here's the terrifying part. The energy released from such an impact would have been comparable to the explosion of 1,000 nuclear bombs detonating at once. A collision on that scale could devastate the planet within minutes, potentially triggering a global mass extinction. The discovery placed enormous pressure on scientists around the world. They realized that humanity desperately needed a way to defend Earth from dangerous asteroids before it was too late. But don't worry, today our technology has advanced to the point where we can actually change the path of an asteroid heading towards Earth. And if necessary, we can even slow it down before it becomes a threat. Sounds like something straight out of a science fiction movie, right? Well, it's real. In fact, NASA has already proven that it's possible. A NASA mission successfully changed the orbit of an asteroid for the very first time in human history. This achievement marks one of the biggest milestones in space exploration because, for the first time ever, humanity has demonstrated that we may be able to protect Earth from future asteroid impacts. After all, millions of years ago, it was an asteroid impact that wiped out the dinosaurs and transformed life on our planet forever. Today, we're finally developing the technology to make sure history doesn't repeat itself. So let's find out, what exactly did NASA accomplish? Why was this mission such a massive breakthrough? And how did they actually pull it off? Well, every space exploration mission we've conducted over the years has revealed one important fact. Thousands of asteroids are constantly orbiting in Earth's neighborhood. To be more precise, there are over 2,000 known potentially hazardous asteroids. If even one large asteroid were to collide with Earth, the consequences could resemble the Chicxulub impact that struck our planet roughly 66 million years ago. The same event believed to have wiped out the dinosaurs and nearly 75% of all life on Earth. That's exactly why NASA has spent years developing ways to defend our planet against this kind of threat. Eventually, they launched a mission designed as a planetary defense experiment, one that could someday save Earth from a catastrophic collision. The mission was called the Double Asteroid Redirection Test, or simply DART. The objective of DART was surprisingly straightforward: crash a spacecraft into an asteroid and see if its orbit and even its speed could be changed. To safely test the idea, NASA selected the Didymos Binary Asteroid System, located nearly 11 million kilometers, about 6.8 million miles from Earth. That way, the experiment posed absolutely no danger to our planet. Within that system, NASA targeted a small moonlet called Dimorphos, measuring about 160 meters, 525 feet across. The mission plan was simple: strike Dimorphos at high speed and push it slightly off its natural orbit. The date was set. Now all that remained was the launch. On November 24th, 2021, a SpaceX Falcon 9 rocket lifted the DART spacecraft into space, beginning its journey towards its tiny target. After traveling for nearly 10 months, the spacecraft finally reached its destination. Then, on September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART slammed into Dimorphos at a staggering speed of nearly 22,530 kilometers per hour. And the moment of impact looked like this: 3, 2, 1. Oh my god! Wow! The incredible impact was captured by both the Hubble Space Telescope and the James Webb Space Telescope, but each saw it in a completely different way. Hubble observed the collision in visible light, while James Webb captured it in infrared. By combining data from both telescopes, scientists were able to study not only the asteroid's surface, but also exactly how the impact changed its orbit. The images revealed something fascinating. After the collision, a massive cloud of dust burst away from Dimorphos in every direction. Some of those dust streams even appeared to curve through space, creating patterns scientists are still trying to fully explain. Although researchers are continuing to analyze the data, one thing is already clear: the DART mission worked. For the first time in history, humanity successfully changed the orbit of an asteroid. That single achievement marks the beginning of a completely new era, one where we no longer have to simply hope a dangerous asteroid misses Earth. We now have the ability to fight back. But DART was never NASA's entire planetary defense strategy. It's just one piece of a much larger system. NASA's planetary defense program follows four major steps. First, find. Powerful ground based and space telescopes constantly scan the skies, searching for near Earth objects and calculating their size, orbit, and the chances of a future impact. Second, warn. If a potentially dangerous object is discovered, NASA's Planetary Defense Coordination Office quickly shares accurate information with governments, scientists, emergency agencies, and the public. Third, coordinate. Space agencies around the world work together to develop a response plan, while emergency organizations prepare for every possible scenario if an impact cannot be avoided. And finally, mitigate. If the threat is serious enough, technologies like DART can be used to alter the asteroid's path before it reaches Earth. Instead of reacting after a disaster, humanity now has the chance to prevent one before it happens. And that's what makes this mission so historic. What's even more exciting is that asteroid defense may not be the only benefit. Many asteroids contain enormous amounts of valuable metals like iron, nickel, platinum, and even gold. In the future, scientists believe we could redirect certain resource rich asteroids into safe orbits, making space mining far more practical than traveling deep into the solar system. The technology isn't ready yet, but DART proved something incredibly important. If we can change an asteroid's orbit, one day we may be able to move them wherever we need them. That could transform not only planetary defense, but also the future of space exploration, resource gathering, and even the global economy. Just a few decades ago, protecting Earth from an asteroid sounded like science fiction. Today, it's science. And this is only the beginning. So here's a question for you: how soon do you think asteroid mining will become a reality? Share your thoughts in the comments below. If you enjoyed this video and learned something new, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey into the universe. Until next time, stay curious and keep learning.